Good evening all. Welcome to this evening's webinar on maths methods, simulations and optimisation, a favourite topic of many and with some great activities that are in store for you. Our hosts this evening, Stephen Crouch and Frank Moyer, both from Frankston, Victoria fame. My name is Brian Lannon. I'm your host for this evening, and stitching all the slides and presentations together. As I said, our first presenter will be Stephen Crouch, currently teaching at Frankston High School. In our T-cubed family of Australian trainers, which number about 30, we recruited 2 rising stars last year. Stephen is one of those. Good evening, Stephen.
Good evening, Brian. Thanks for the really good introduction. You're making me blush over here.
Very good, very good. But well credentialed, as we can see. Teacher of the senior maths, also writer of exam questions, and absolutely a valuable member joining our team.
Thank you, Brian.
Our other presenter this evening, Frank Moyer, who formerly taught at Frankston High School, same school, and with 30 years or more teaching under his belt, similar to myself. So the old guard, experienced and expert, and I always enjoy hearing from Frank and attending his sessions. Good evening, Frank.
Good evening.
I see in your bio there the mention of using rich tasks and investigative approaches, absolutely classic and most pertinent to the topic of tonight's webinar.
Yes, indeed.
I've seen the files that you've sent me, and you have some of my favourite activities. Simulations, I think, is the real power of using the technology. And the links through to calculus. I love probability and I love calculus, and I think we've got a bit of both happening this evening.
That's right, yeah, that's right, yeah. That's right,
so,
exactly right.
All set, Stephen? We can
yes,
see your screen, and it looks fantastic.
Yep. Excellent. Thank you very much. Okay, well, good evening again, everyone. Thanks for tuning in. You've got an absolutely brilliant webinar ahead of you. Frank's got some really good stuff, and I've hopefully got some good stuff as well. So just as a quick sort of run of the agenda, I guess, I'm starting with a couple of calculus problems. So as you can see, we've got shapes in a parabola, where I've got a bunch of parabolas, and I'm putting shapes inside there and analyzing the area, etc. I'm then going to move on to shapes in general graphs, such as bell curves and circles. And then we'll look at the classic calculus problem where we have the minimum distance between a line and the origin. Then a bunch of paper folding stuff that I've actually shown previously, if we get some time. And then something about solving trig equations and visually demonstrating the concept. And then the classic calculus volume of a box. And maybe if we get some time, how the graph of y equals sine x is generated from the unit circle. So as you can see, plenty in here, hopefully enough to pique everyone's interests. So without further ado, let's make a start. Okay, so as you can see, we're going to start with shapes and parabolas, and let's dive right into it. So my first problem is a rectangle inside a parabola. Effectively, I've got the parabola y equals 81 minus x squared, and our job is to take a rectangle, put it inside the parabola, as you can see in this diagram here. And our job is to try and find the maximum area of that rectangle. You might notice a problem very similar to this appear in a typical maths methods or even specialist maths textbook. It's a typical sort of question on calculus and any sort of optimization. So what I will be going through is how to simulate it, or I've simulated the entire thing already, and I want to show you how we can use data capture and a list and spreadsheet application to actually track the x values and the area values as well of this particular rectangular shape here, and then we can simulate what happens to the area as x changes. So currently, I've got a situation where I've got x equals 5 and y equals 56. That's just straight out of the function, really. And the area of the rectangle that I've generated is currently at 560 units squared. So before I start modifying that, I want to show you what I've got set up already anyway. So I've got a lists and spreadsheet application, one with a column has x plot on it, and another column has a plot. As you can see, I've got the x value, which is 5, and the current area, which is 560. What's going to happen is once I grab this point, as you can see, I've made it gray and slightly bigger than the other one to highlight its importance. Once I grab that point and start moving it along the parabola, what's going to happen is this column and that column are going to now generate and basically fill up with a bunch of values. What's then going to happen is those values are going to get plotted onto a scatter plot that I've got going on here. And then at the end, what we're going to do is I've got a little slider down here, which will control the analytical solution of this problem. So we can check the validity of our simulation. So if you were showing something like this to students, it really takes them through the entire process of mathematical modeling. You set up the problem, you define your variables, you get your diagram, then you go through the algebra or calculus or whatever it may be. But before you even do that, it's a really good idea to actually visualize the simulation. So I'm going to do exactly what I said before, which is grab this point and slowly move it along. As you can see, the x values are decreasing, and so is the area. I'm going to slowly decrease that all the way to maybe, let's say, 0, and then likewise take it all the way back down to the x-axis. So if you were doing this with students, by the way, this file and all the files I'm showing, as well as Frank, as well as what Frank is showing, they will be made available to you after the webinar. So please feel free to take these files. You can modify it if you wish, and show it on the projector to your classes to show them how this whole thing works out. So if I was showing something like this to my students, I would encourage them to have a very close look at that area over there and see what happens as I start changing the x value. So what you can kind of see happening is that around this area, yeah, about 540, 560, 561, there we go. At about 561 or so, it swaps from increasing down to decreasing. So we can see that around this x value, we're basically getting the maximum area. So to sort of further demonstrate that, as you can see, as I said before, this entire table has now populated with all the different x values and area values that I've gone through on the simulation. So going back to the scatter plot, wow, that looks nice. So this right here is a scatter plot of all the x and area values, correct, all the x and area values that were generated from the simulation. So to see whether this fits the theoretical and analytical solution, I'm going to turn the graph on. Okay, can't really see it that well, but if you can have a look there behind the scatter plot, Brian and Frank, can you see the graph of A of x behind it?
Yep. Slightly different.
Yes,
color.
looking
Right
good. Yep.
Looking good, yeah. So I think I can say with fair confidence that our simulation and the scatter plot we've generated does agree with the analytical solution. So as you can see, just a very basic, simple, elementary calculus problem like this, the TI-Nspire can be used to really gain a really good understanding of it. I find that with the students that I teach, and I'm sure with the students that every one of you teaches, a visual representation of any mathematical concept really does wonders. And just doing that for whatever the situation may be, whether it's calculus, trigonometry, etc., it just works wonders. Okay, so without further ado, I'm going to move on to the next problem. And this time I've got a triangle inside a parabola. So this time I've got a triangle which has its vertex at the origin. I've got the exact same parabola as before, 81 minus x squared. And our job is to find the maximum area of the triangle, very similar to the way we found the maximum area of the rectangle. So again, I've got the same setup. I've drawn a diagram of the scenario we've got. We've got our triangle there. We've got our coordinate, just so that's sort of defining the setup of the problem. And then going to the simulation, we've got the same thing going on here. I've got my gray point there that I'm going to modify, and I've got my my spreadsheet set up. I've got the scatter plot set up as well, and I've got my little selector at the bottom telling me or asking me, do you want to show the analytical solution or not? By the way, when I get to the shapes in a general graph, my second example in that one, I will actually take you through a similar problem like this. It's a triangle, and I'll take you through the steps I go through when I make a file like this. And as you'll see in due time, it's actually not that hard. This sort of thing might look quite complex and difficult to do, but just with a little bit of learning of the geometrical properties and the menus of the TI-Nspire, you too can make files like this. So I'm going to take this point here, and as before, I'm going to drag it. And as you can see, the triangle slowly becomes nothing. And as I take it down to the bottom, it becomes nice and wide. And there you go. Again, you can tell students to have a look at and focus on this top right-hand area function there. And as you can see, it increases, it keeps increasing. And then eventually at one point, it will start decreasing. There we go. Around the 280 mark for the area, it increased and then it reached maximum and then it started decreasing. So let's see graphically what that means. Oh, there we go again. We've got a similar sort of scatter plot happening. I'm going to press this button and there we go. You can see the green graph right there behind the scatter plot. And yet again, our simulation has agreed exactly with the analytical solution. I reckon that should instill some confidence in your students to show them that what you're actually going through is legit and you're not just making stuff up, as sometimes happens to be the case. Sometimes you get called out. And a simulation like this is perfect to just sort of take a step back and say, hey, look, this is what's happening. Here's the equations. Well, this is how the equations agree with the shapes.
Right. Yeah, it gives the other representation. Yep.
That's exactly right. Yeah. Just the fact that we've got a dynamic, dynamic representation and simulation. I think that just really does works wonders. I wish I had something like this when I was a student. I certainly would have understood maths a lot more than I did back then.
That's an interesting reflection. Yeah, and you were saying in the warm-up that already you see that this has really empowered your teaching.
Correct. Exactly right. Yeah. Like as soon as I started getting the hang of TI-Nspire and its dynamic capabilities, just my teaching methods and the excitement I had with my teaching just really shot through the roof. I think my first derivative is still positive, so I'm still yet to get to the maximum, but I'm digressing over there, so I'll leave that story for another day. So here we go. Here's let's just go to a different one where we've got a general graph. So here's a problem where I've got a rectangle sitting inside a circle. Quite a simple one. A rectangle is sitting inscribed in the unit circle. Our job again is to find the maximum possible area of the rectangle. So again, I've got the same sort of setup here. The blue graph there is the unit circle. That gray point there is the one I'm going to modify. There is the list and spreadsheet with everything set up inside there, and there is the area scatter plot axes ready to go. So again, I'm going to do the same thing. I'm going to drag that, take it down to the bottom, take it all the way to the top. And again, you would tell the students to have a look at that area over there, how it increases and then decreases again. Again, as you can see, we've got a nice graph made from the scatter plot that we've had. I'm going to turn the area function on, and there we go. So basically, in case you're wondering, with all the previous examples that I did, this a of x function is one that I just generated previously. So if I go back to the function, there, 4x times square root 1 minus x squared. So this is the function that you would create while you're going through the analytical solution. So you can talk in depth with the students about where that comes from, etc. And then when you superimpose that onto your simulation scatter plot, you can clearly see that correlation between them. In fact, you can see that they're exactly the same thing, which is really good, powerful visual tool. Okay, so I'm now going to move on to the final shapes simulation, I guess you could call it. This time, I've got a triangle, just like I had with the parabola, but this time the triangle is living inside a bell curve. So it's not really the standard normal distribution. All I'm doing is I've just simplified the normal distribution down to have a coefficient of 1 on the e and a coefficient of 1 on the negative x squared as well. So it's the same sort of shape, just with all the dilation factors removed. It just for the sake of simplicity and to make it a bit easier to deal with. So this time I've got e to the negative x squared, which is our bell curve, and we've got the third vertex sitting on the origin. As you can see, I don't actually have the triangle set up, nor do I have any of my scatter plot or list and spreadsheet set up, because I want to actually go through how you would go about doing this. I'll get through it pretty quickly in the interest of time. There's only about 10 minutes left. I don't want to eat too much into Frank's time. Okay, so the best way to do this is, of course, you start off just by typing in the function, which is e to the negative x squared. Nice and straightforward. Of course, I've pre-prepared this by making the window settings appropriate for the scenario. You would have to do that yourself after putting in the function. Once you've done that, you can then go to Menu, then to Geometry, 8 for Geometry, then 1 for Points and Lines, and then 2 for Point On. I could of course go for Point, but Point On locks your point onto the graph. So I click Point On, and then I'm going to hover over the graph, press Enter again, and now as you can see, what happens is if I move away, I don't get anything, but as soon as I get onto the graph, it puts a point there. So once I put the point there, what I can then do is go back to Menu, Geometry again. This time I'm going to go for Transformation, and because what I'm going to do is I'm going to reflect that point in the y-axis. Because this graph is symmetrical, what's going to happen is that point is going to reflect over to the y-axis, and that will make the third side of the triangle parallel to the x-axis, as stated in the problem description. So going back here, what you have to do is once you've gone through those menu options, you have to first click the line of reflection, which in this case is the y-axis. So I'm going to click there, and then I'm going to go and click the point. So you click the line of reflection, then you click the point that you're reflecting. Then I hit Enter or mouse click, then I press Escape, and as you can see, what it's done is it's taken that point and reflected it in the y-axis. So what's going to happen is I can grab that point and now start moving it, and what happens is because this bell curve is symmetrical, it just takes this point, reflects it, and goes there. So that's a good enough way, a nice and easy, simple way to get those 2 points going. What you can then do is, as I had in my previous examples, I can make this gray just to make it more, I guess, noteworthy. So I can right-click, go to Color, Medium Gray, and now it's gray point. So it shows that I guess it's special in some way. Then after that, what I'm going to do is I'm going to create the triangle. So I'm going to go to Menu, Geometry, Shapes, and Triangle. So to create this triangle, I'm going to start at the origin, which it classifies as the intersection point of the x and y axes. And then I'm going to go to that first point, and then I'm going to go to the gray point. And what do you know? We've got a nice triangle over there. If you want to make sure that you've got it right, just grab that gray point and start moving it. So there we are. There's our triangle taken care of. So now, of course, the question is, how do you bring the area into it? Because, of course, we are talking about the maximum area of the triangle. So to bring the area into it, what you can do is right-click. This is on the computer. Or if you're doing this on a handheld, you can press Control and Menu for right-click. What I'm going to do is I'm going to right-click this triangle and then go to Measurement and then go to Area. What it's done is it's taken the triangle and found the area, which currently happens to be 0.427 square units. Just carefully watch that area as I move the point. As you can see, it's all dynamic. Everything is linked together. So as I move that point, that area will, of course, change with respect to the different x values. So what we're going to do is, before we start setting this list and spreadsheet up, I'm going to first define this value, which is the x value. I'm going to store it as xc for x coordinate. So now it becomes bold to tell us that it's now basically putting that value into the calculator's memory as xc. Of course, the other quantity we're analyzing is the area. So we're going to right-click that again, go to Store, and type in AREA for area. There we go. There's the area, and there is our x value. Now, as you can see, as I start changing this, both the x value and the area change as well. So what I'm going to do, I guess let's make this look a bit more nicer. I'm going to right-click that, color, fill color, and I feel like orange, so let's make it orange. So there we go. There's our orange triangle ready to rock and roll. So let's go to our list and spreadsheet. So what we need to do is we now need to define new variables that are going to basically collect all the xc, which is this, and all the area functions. So what I like to do is, from my previous ones you might have noticed, I call this x plot for the x values being plotted, and I go to I go to that cell there, and I type in a plot to represent area plot. So what we're going to do is, in the equals box here, I'm going to go to Menu, Data, Data Capture, and Automatic. So what this does is it's going to tell the calculator to take all the xc values, which is all the x coordinates, and it's going to capture those values into column A. I'm then going to go to the formula box for column B, go to Menu, Data, Data Capture, Automatic, and type in area. Of course, if you don't want to type it in, you can, of course, press the var button and then find area from there. I think it's going to put that there. I'll just remove that for columns and variable references. I'll just make it a variable reference. Hit enter, and there we go. So what this means is, for an x value of 0.91, we have an area of approximately 0.4. So if I go back here and I start moving this graph up and down, you can see what's happened is the calculator has gone and populated these columns with the respective x values and area values. So how do you now plot those as a scatter plot? Well, that's quite easy to do, and I'm going to show you how. So you press Menu, Graph Entry, and Scatter Plot. So the scatter plot is going to ask you for the list of x values and the list of y values. So as we saw from the previous screen, our x values are listed in xplot, and our y values are listed in a plot. So that's what I'm going to do. I'm going to go here and press var, xplot, go down there, var, a plot, and I hit enter, and there we go. We've got a pretty good distribution of values over there. Now, if you wanted to, if you see this and you think, oh, look, that might not be enough to show a full picture of the entire scenario, by all means, you can come back to the diagram and then start trying to go over many more x and area values. So you can go through this multiple times to give the calculator more values to work with. But once you get back to the scatter plot, it's gone and dynamically updated everything throughout the scenario. I reckon that's pretty nice, isn't it? And
Absolutely.
then what you could, that's exactly right. And then what you could do is, again, you can, previously you've done the analytical solution. You come back here, show the area function, and there you go. The proper analytical area function is nicely sitting flush with the scatter plot. I reckon that's pretty amazing stuff. Okay, so that concludes my my shapes presentation, I guess. I'm now quickly going to move through the rest of the few things just to show you what the TI-Nspire is capable of. Given I have only about 2 minutes to go, I'll rush through them pretty quickly. So my next one is a minimum distance question, where I've got the graph of y equals 10 minus x, as you can see. I've restricted it to the first quadrant just for simplicity. And I've got a line segment that goes from the origin to any point along the curve, along the line, sorry. I've also asked the calculator to calculate the angle between the line OP, which I've got there, and the actual line itself. And as we start moving up and down along the line, I've also got my data capture set up, and I've got a scatter plot going of that as well. So as you can see, there is an x value which is around here at which the minimum distance will occur. Of course, you can also look at that as the point at which that angle becomes exactly 90 degrees. And then you can see the distance change depending on that. So if I move away from 90, that 7.07 is going to increase. I go away from 90 this way, again it increases. So clearly, the minimum distance we're getting is at 90 degrees, which is what we would hypothesize. So once I've done that, the next one is a paper folding calculus. I've done this one in a previous webinar before. I'll show you quickly what the deal with this one is. Here's a piece of paper, and what we've done is we folded it in such a way that the top left corner gets folded to the bottom side of the paper. And if you start changing how much fold gets done, you can again data capture it, and again we create a scatter plot. Where's another one? Another calculus-based one. This is the classic calculus volume of a box problem. I don't claim to have made this file. This was made by a gentleman, I think in the Netherlands it might have been, if I'm not mistaken. This was created using Lua code, which is the code behind the TI-Nspire. It's an absolutely brilliant file. You can change the length of the cutout that you take from the corner, and then there's a slider that controls how much fold gets done. And what you can also do is change the width and change the length of the initial piece of paper, as it may be. So it's quite a nice one to demonstrate that idea to students. It's the typical sort of problem that you start off a calculus modeling sort of class with, and this is a good way to get the students to start thinking about what we're doing in real life. So we really finish off with a couple of trigonometric things. With this particular file, I actually made this within about 10 minutes while I was in class and waiting for the students to do something else. I was about to teach what the meaning of solving sin x equals half was, and I thought what better way to do it than to create a unit circle and then to take a point and to create a segment between that point and the y-axis, and then also track the y value as you start moving along there. So what I said was, if you take this unit circle, drag that point until you get y equals 0.5, you have now found the first solution for the equation sin x equals half, or sin x equals 0.5, assuming, of course, that you're starting at an angle of 0. And then, of course, that brought about more discussions about, well, are there any other positions on the circle, on the unit circle, where you get y values of 0.5? And of course, with a diagram like this, you can take it all the way to the left, you end up with a y value of 0.5, and there's your second solution. And that's a really good way to introduce the idea of solving trig equations. That's for sine. I made another one for cos as well. Again, of course, it goes with the x-axis. So if you're solving cos equals 0.5, well, there is the same deal again. So to finish off, I'll get through this one really quickly. Here is a unit circle, and there is a slider. What I can do is I can right-click that slider, click animate, and what it does is it slowly increases the angle between the x-axis and the angle line. And what happens is, as the y value of this of the point on the circumference changes, it slowly starts generating the graph of y equals sine of x. Again, this one is not my file. I've just taken it from the TI Australia website, and I've used it to show how the graph of y equals sine x is generated. Of course, at the bottom, there's a few tips on what's actually going on, but you can literally just put this up on your projector, hit the animate button, and just sit back and watch the TI-Nspire do its thing, while the students sit there in awe at what you've just pulled off as a magician, or rather, should I say, mathematician. So I think I'll put a stop to it there. I think Frank's got a lot of stuff to go through, so I'm not going to take away the time for that. But hopefully you've had a good time watching what I've had there to present. Hopefully you will also get to use some of this in your classroom. It will really make the students let the students be in awe as to what you can create. So all the best with that, and hopefully you can get to use those files when you can.
Terrific. Thanks very much, Stephen. A couple of interesting points there. Firstly, you acknowledged taking, shall we say, second-hand files from the user community, and I think absolutely yes, that's a smart thing to do. Why reinvent the wheel every time? Some of those, I refer to some of those activities as absolutely classic, like the construction of the box from the piece of paper, and I would do that every single time I have a different calculus class. It's just one of those classic ones that I think a lot of us use for illustrating optimization. I have students actually guess first and then cut out the corners on an A4 piece of paper, collect some data, and then start plotting that, and then try to match, of course, the cubic model. But how lovely to then just grab that file that you've shared, that you're sharing with us and all the participants. That can, if that activity is part of your teaching repertoire, then it's handy to just slide that file in.
That's exactly right. Yeah.
As well, of course, with the unit circle and development of the sine curve. Well, what a classic! I think every one of us would do something like that every time we introduce that topic.
Of course.
Yeah. Just before I move on to Frank there, we did have a question there. When you've used the setup to populate the lists in the spreadsheet with the
data capture, yes.
With the data capture, a question was put as to how can we delete that data if you wanted to start
how can we delete? Okay, it's quite simple. It's a bit hard to show that without my screen, but I'll try and describe it. When you have your spreadsheet, the second row is titled the equals line. It's the formula line. All you have to do is click the cell in that line for whether it's column A or column B, then press you can just right-click that, and then option 9 is clear data. So you just have to right-click the row in the equals the equals row, whichever A or B. You can do both of them as well. Right-click that and clear data, and it just clears the entire column except for the first row, which it shows for the current data point. So you can clear up all the ones that you've created. Yeah, so it's quite straightforward to do. You right-click on that and click clear data, and it's good to go.
Fantastic. And I think without seeing your screen, I think that's been a terrific explanation. Of course, the one data point would still be held because that's where the cursor will be. Thank you very much. Frank, we can see your screen in full colour, and it's looking good.
Excellent. Thank you, Brian, and welcome everyone. As you can see, for my part of the webinar, I'll be looking at simulation in probability and statistics, and I think that it's really important that we use simulation, especially in developing a sound understanding of the sampling distribution for statistical inference. But in today's webinar, I'm not going to focus on statistical inference because I think that that topic deserves a webinar in its own right in Unit 4. And of course, in the Victorian context, it is explicitly, simulation is explicitly required in the study design. So in Unit 1, simulation using simple random generators such as coins, dice, spinners and pseudo-random generators using technology to display and interpret results. And in Units 3 and 4, simulation of random sampling for a variety of values of P and a range of sample sizes to illustrate the distribution of the random variable capital P hash. Now, what I'm going to be looking at today is something a bit simpler than the sampling distribution. I'm going to look at simulating, first of all, the sum of two dice. Now, this would be relevant if you were, for example, simulating the casino game of craps. Now, in this game, two dice are rolled, and the sum of the numbers appearing uppermost is noted. So the player wins if the score in the first throw is a 7 or an 11, and the player loses if the score is 2, 3 or 12. For any other score, there are other rules that apply. But I'm only going to concentrate on what happens in the first throw. Okay, so before carrying out a probability simulation for the first time with your class, it's important to seed the calculator because the Nspire doesn't generate true random numbers, they are pseudo-random numbers. An algorithm is used to generate them. So if all your students have their brand new calculators, when you start doing the simulation for the first time, they will all get the same results. Now, to see the calculator, very simple. You can just insert Control-Doc or Control-I, a calculator application. You can go to the menu, probability, which is 5, and random, which is 4, and seed, which is 6, and then I just get students to put in the last 4 digits of their mobile phone number. And
the PIN number.
Okay, so and you don't have to repeat that, so that's done until the next time that the students upgrade their operating system. Okay, so we're going to start by simulating in a list and spreadsheet application, and we're going to, in the first column, simulate rolling the first die, the second die in the second column, and then the sum. Now, what I'm going to do is I'm going to set the number of trials in this cell here. Now, at the moment, that's just text, but if you get the context menu, which on the handheld is Control Menu, and you go Variables, 7, you can store the variable. So I'll store that as a variable N. And you can see it's bold because it's a stored variable. Now, what I'm going to do in that cell is I'm going to have a random integer between 1 and 6. So I can get that from the catalogue, so that's the big book, and I'll go press R to go to for random. Now there's various random, I want random integer, and if you note down the bottom it tells you the syntax, the lower bound which is 1, the upper bound which is 6, and the number of trials. So random integer, I want random integers from 1 to 6, and I want n of them, and n, and it asks you, so do I want a column reference or a cell reference? In this case, or a variable reference. I want a variable reference, and there we go. Now, I want to do the same thing again. Now, the shortcut way of doing it is just to press, with that cell selected, Control-C for copy, Control-V for paste. Yes, it will overwrite, that's fine. And you'll see down the bottom here that it hasn't copied exactly, it's actually translated from the column named die 1 to column named Die2. And over here, I want the sum of those. So equals whatever is in the column Die1 plus whatever's in the column Die2. Okay, so that's pretty straightforward. Now, the next thing I want to do is to get a frequency table of those results. And of course, if I want to repeat that simulation, I can just press Control R, and every time I press Control R, presumably for repeat or recalculate, I get a different set of results. So if I want to collect those, what I can do is, here I want the total, so the total I can, between minimum is 2, 1 plus 1 is the minimum, and 6 plus 6 maximum, so 2, 3. Now, in a spreadsheet, if you want to continue a sequence like that, you can multi-select by pressing the Shift key, hold down the Shift key and press the arrows, and then if you get the context menu again, so Control menu or right mouse click if you're using the software, Fill, and press the down arrow, and it's continued that sequence. And now the frequency, I want equals, I want to count if in this list back here, in the list called the die sum, if the number equals 2, I want it counted. If the number equals 3, I want it counted, and so on. So count if, now I can get count if once again from the catalogue. So I'll go C, actually I'll go D and work up, because I think count should be near the bottom. Count if. Now, you can see the syntax. So count if, it's the list, comma, the criteria. So count if the die sum, now I want it to equal 2. Now 2 is in my cell A1, so I can just type in A1. And because A1 is a relative cell reference in the spreadsheet, if I fill that down, it will update to A2, A3, and so on. So once again, I can Control menu, context menu, fill, number 6. I can go down, and bingo, I've got those. If I want to go to the top of my spreadsheet, by the way, Control 7 takes you to the top, Control 1 takes you to the bottom. All right, so that one equals B1 divided by N will give me the success fraction. If I want that as a rational approximation, I can just have 1 decimal point times B1, and I get the rational approximation. And again, I can context menu and fill that down. All right, and what I can now do is I can insert a data and statistics, and if I tab and I go for the die sum, I can see a distribution. And if I go back and press Control R, the distribution will have changed slightly. So wouldn't it be nice if I could actually recalculate from within my data and statistics page? So that's an enhancement. This is one I prepared earlier. Okay, so the enhancement is you can add a slider to so that the number of trials can be recalculated, and so the number of trials can be set, and the recalculation can occur within the data and statistics page. So I've put a slider here where I can control the number of trials, and I can recalculate. All right. Now, all I've done here, I've put in a slide. To put a slider in, it's just Menu and Actions, Insert Slider. Now, how does this slider with the variable, I've called that variable R, how does that R force the spreadsheet to recalculate? Well, it's a very simple trick. I've gone in the spreadsheet, the spreadsheet here. I've still got my random integer 1 to 6, comma n, and then I've added plus r minus r. So whenever the value of r changes, it forces that list to be recalculated. Yep. So I could have plus r minus r. You can also use plus or times the sign of r, sign as in S-I-G-N. That also does nothing other than force a recalculation. Okay, and
sneaky tricks, quite clever.
All right, so you could then extend this to, that's only the first part of the game of craps. It can then get quite complicated if you're then going to have a look at what if you neither win nor lose in the first throw. So then you could extend this simulation and it starts to get a bit more complicated. Okay, but rather than extend the game of craps, I'm going to have a look at a different one, the Monty Hall problem. So the Monty Hall problem is based on an American game show where the host was Monty Hall. And in part of the show, there were 3 doors behind which there was a prize, which I think was a car, and behind the other 2 were goats. Now, as a farmer, I'd prefer the goat to the other prize. However, the goat was supposed to have no value, and it was the prize that people were after. So this is how the rules went. So a prize is hidden behind one of the doors. Goats, which are deemed to have no value unless you're a farmer like me, are behind the other 2 doors, and the contestant chooses a door. The host then opens a door that was not chosen by the contestant and which does not contain the prize. The contestant is then given the option of staying with the original choice or switching to one of the remaining closed doors. So to maximise the probability of winning the prize, should the contestants switch their choice or stay with their initial choice, or does it make no difference whether they stay or they switch?
Frank, it sounds like we should ask the participants. I'm opening a poll on it.
Okay, yes.
See what we get.
That's right. So let's see what you get. Okay. All right, now when students first see this problem, and not just students, but people generally, including mathematicians, they tend to say, well, it makes no difference, and the reasoning is this. Suppose that the contestant initially chooses the middle door and the host opens the door on the left to reveal a goat. There are 2 closed doors remaining, therefore whether the contestant stays with the middle door or switches to the other door, there is still a 50-50 chance of getting the prize, which sounds plausible, but is it correct? Well, let's simulate this. So the assumptions in the simulation, we're going to assume that the prize is behind the door which we label 1, and the goats behind doors 2 and 3. So these are not necessarily first, second and third doors from left to right. So 1 is just the one with the prize, the other 2 are the ones without the prize. If the contestant's initial choice is door 1, the host makes a random choice between door 2 and 3 to be opened. If the contestant's initial choice is door 2, the host opens door 3 and vice versa, and we will conduct 100 trials in the simulation. Okay, so in the first column, we're going to have the door initially open, so we're going to use a random integer generator from 1 to 3. Then we're going to use if statements to decide which door the host opens. And then in the third column, we're going to find out whether that's a win or a loss if they stay, and a win and a loss if they switched. Okay, so what we've got here is random integer from 1 to 3, and we've got 100 of them. I've already shown how to do that. In this cell, I'm going to use an if statement. Now, an if statement, it's if fn. Now, there are two if the if statement is just if and then the Boolean expression. That's what you would use if you were using an if statement in a program. If you're using the if statement in something like a spreadsheet, it's if function. So it's the Boolean expression, the value if true, comma, the value if false. So this is the logic. If A1, that is, if the first door equals door 1, then the host randomly chooses between door 2 and 3. Otherwise, if the first choice is door 2, choose door 3, otherwise choose door 2. So it's a nested if statement, an if statement within an if statement. And here, the if statement to decide whether you win or you lose. If A1, if the first choice is 1 and you stay, you automatically win. Otherwise, if you switch, you lose. Then, in this one, if you win, if you don't, if you switch, you win if the first choice was either door 2 or door 3, in which case the sum of these two cells is 5. So that's the logic there. And over here, what I've done is I've counted the number of wins in the stay column, and here the number of wins in the switch column. So I can now multi-select, so you just hold down the Shift key to multi-select, then Control menu to get context menu filled down, and even though we're doing 100, it doesn't take very long. I did this on the handheld this morning because I have to confess I almost never use the handheld myself, except I want to practice whether what I'm going to demonstrate actually works just as well on the handheld, and it does. Control 7, and if I press Control R, I recalculate. Now, wouldn't it be great if I could also capture into the multiples of 100? So instead of restricting myself to 100, if I could capture those results, I could have been 200, 300, 400, and so on. And so I've done that using capture, which Stephen has already showing you how to do, and it's I'm capturing the stays if you win, and the 1 is automatic. And now when you're using data capture in probability, it's important to have something that's changeable. So I've created this variable here, ch, this variable ch, which all it is random. So it's a random number. The reason for that is that when you're doing data capture, if you get the same value twice, twice in a row, it thinks, oh, I've already captured that, I won't capture it again, and therefore you'll get erroneous results. But if you put that comma, some variable that changes, then it will capture both of them, even if they're one after the other. Anyway, it's just a little trick. Okay, and so if I go back and I do Control R a number of times, no, I was wrong one. It's this one I wanted to do several times. Okay, so as Stephen showed, it populates the spreadsheet, and I can see these results here. This is the simulation number against the win if you stay, the win if you lose. And it's quite clear that if you, win if you stay, win if you switch, and the switch definitely is ahead. And wouldn't it be good? Oh, by the way, I'll just illustrate what Stephen was saying about clearing those lists. If you go, if you select that whole list and you control menu and you go data, clear data, data, clear data, and it clears the data. The other way you can also do it is go back and just press enter, enter. Go back to the capture, enter, enter. All right, and you can also set up a little slider so that you can control it from the data and statistics. Once again, using that trick, that plus R minus R trick. All right, and we can see that this one is converging. This is just now getting the average of the proportions. So with the stay, it's
looks about 1/3.
About 1/3, and with the switch, it's about 2/3. And you can actually prove that, show the convergence by going to menu, analyze, plot function, 2 divided by 3, and there you go. And lastly, I'm going to have a look at another simulation involving derangements. Now, in the multi-hall, that's one of those counterintuitive problems which the simulation is quite convincing. The derangements, the mathematics is far beyond what method students or even specialist students are expected to be able to do, but they can still simulate. So derangement is a permutation of elements of a set so that no element appears in its intended place. Now, this is one that I actually did talk about in a previous webinar. So I've got 12 letters and 12 envelopes. If I place the letters in the envelopes at random, what's the probability that none of the letters will go to their intended recipient? And so I've got the simulation here. I'll just keep repeating, and so this shows out of 17 times that I've done this, out of 29 times, that shows how many times none of the letters went to the correct recipient, one letter went to the correct recipient. This is out of 12 letters, all right? And I can just keep repeating the simulation. Okay, and you can see the proportions there. So the probability that none of them go to the right recipient in that simulation, it was about 0.37, the theoretical, 3.789, the theoretical is 0.3678, and if you go to that file, if you get that file after the webinar, you can also see the theoretical probability for when you've got 1 letter, 2 letters, and so on, and the theoretical probability that none of them end up in the going to the correct address. Okay, and I think that my time is well and truly over, so thank you very much for your attention.
Yeah, thanks, Frank. I'm just saying there, and I realised I had my phone muted. Our presenters, Stephen and Frank, some terrific ideas shared there. And a reminder that you will be getting the follow-up files from this evening's presentation, also a certificate of your attendance, arriving to your inbox soon. If you would like to view this webinar again, please do so either on Texas Instruments Australia YouTube channel or from our web page by selecting Webinars on Demand. You see the links there on your screen. So either go education.ti.com and then go for Australia, or the YouTube channel that you see on your screen. If you enjoyed this evening's webinar and you would like to join us for more, then coming up next for our webinars for the remainder of Term 2, you see next week we have a webinar on matrices, and also another on for specialist maths on kinematics and solids of revolution. We have a couple of webinars on the International Baccalaureate, and also one on general and further maths, geometry and trigonometry. So please join us for those. If they're the subjects you are teaching, a reminder that on the webinar, on the Teachers Resources page, you have webinars for on-demand viewing, or you can enroll in the upcoming webinars. Also keep a watch of the T-Cubed workshops, upcoming programs, or you can, of course, request a workshop for a network of schools. There is that link to the professional development, or as I said, if you go to education.ti.com and select the Australian site, you can easily follow the tabs to get there. We hope you'll subscribe to our newsletter, which I know is used by many to be alerted to the upcoming webinars. If you are not subscribed to the newsletter, you can follow the link there to do so. Once again, available via the web page. Finally, if you do have any remaining questions about your calculator use or software use, or about our professional development services, phone the numbers on your screen. I do know the people who answer the phones there, and they're pretty clever, so they will be able to guide you. Once again, thank you for joining us for the webinar this evening, and a special thank you to both of our presenters, Stephen Crouch and Frank Moyer.
Pleasure.
All the very best to all, and we look forward to seeing you again. Cheers.
Bye, everyone.
Bye, everyone. Good night.